Well, thank you for joining us on this M2 Centre of Mass support session. We're going to look at a question from a past paper to do with finding the centre of mass. This question has a circle with a circle cut out of it. A uniform circular disc has centre O and radius 4a. The lines PQ and ST are perpendicular diameters of the disc. A circular hole of radius 2a is made in the disc with the center of the hole at the point R on OP, where OR is 2a, to form the lamina L, shown shaded in figure 2. Show that the distance of the center of mass of our lamina L from P is 14/3. So we want the center of mass from P. Okay. So let's have a look at using the area, and let's work from P. So we've got the area and we've got the X and Y coordinates from P. Now the area of our large circle is pi r squared, so we'll go pi 4a squared. And the center of mass of our large circle from P is negative 4a and 0. Now the circle, the small circle, has pi, a radius of 2a squared. Its center is negative 2a from P, 0. And then we've got the total area, which is the area of the large circle, which is pi 4a squared, minus the area of the small circle missing, 2a squared. And then the center of mass is some average x, y position. So we would imagine it to be somewhere on the x-axis, on the other side of O. All right, so let's multiply our area times our position and subtract, because this area is missing, the area times that location of the center of mass. And then that should equal the average of the x average and y average. So let's do that. Pi times 4a squared is 16a squared. Negative 4a, 0, minus pi, 2a squared is 4a squared, negative 2a, 0. That should equal the area, which is pi 16a squared minus pi 4a squared times x bar y bar, the average x and y. All right, so what do we have here? We've got a pi in every term, so we can divide by pi. Here we've got negative 64a cubed plus 2 negatives, 8a cubed. This is just the x components. Equals 16a squared minus 4a squared, so that's 12a squared x bar. Now, for the y bar coordinates, it would be 0 minus 0 equals 12a squared y bar. Therefore, we can straight away see the center of mass for our y position will be 0. And here we've got 56a cubed. 56a cubed equals 12a squared x bar. Divide that, 56a cubed over 12a squared. 2 of those cancel, and let's say 3, no, 4, yes. 4 goes in a 56 14 times, 4 goes in a 12 3. It's 4a over 3 and 14a over 3. I've got the negative here that I've left out. And so therefore, units from P, we can say, because it's left, 14a over 3 units to the left of P. And that is what we were asked to find. Show that the distance of the centre of mass of L from P is 14a over 3. Well, our second task is, the question says this, the mass of L is m. So there's a centre of mass here. Let's put the centre of mass in that position. And a particle of mass hangs particle of mass Km, which is K lots of a multiple of our limiter, is now fixed at L at the point P. So we're going to attach a mass here. Now if we attach a mass, that's going to cause the centre of gravity to move across. Now if we were to just, the system is now suspended from the point S. So we're going to suspend it from this point here and let it hang freely. The diameter ST makes an angle alpha with the diameter vertical through S. Now if we had no mass hanging here, that point would have hung directly below the point S. But as it is now, with a heavier mass here, it is going to weigh this down, and the diameter ST makes an angle alpha with the vertical through S alpha. So when it's hanging, let's assume that it hangs somewhere between these 2 points. That is alpha. And tan of alpha is 5 over 6. Let's just put a point here where it passes through, and let's just call that point. We'll call that point A. We'll call that point B. Now let's have a look at the different lengths that we've got here along our x-axis. Now because tan of alpha is 5 over 6, tan of alpha is 5 over 6, so opposite over adjacent is 5 over 6. So the ratio of OB with the ratio of SO is 5 over 6. Now SO is 4A because that's the radius. So we can say that the ratio of opposite over adjacent is tan of alpha, 5 over 6. Therefore, OB is 20A over 6. And that's 10A over 3. So this distance OB is 10A over 3. And the distance from, say, Q to B is 4A plus 10A over 3. So that's 12A over 3 plus 10A over 3 equals 22A over 3. So we've got the distance from Q to G, got the distance from O to B. Let's get the difference from B to P. That's going to be for a takeaway, that distance here, which was 10A over 3. So we've got 12A over 3 minus 10A over 3 leaves a distance of 2A over 3. And we've already established the distance from O to A. 14A over 3 is the distance from P to O. Therefore, from A to O, is 14A over 3 minus 4A, 12A over 3, so that's 2A over 3. Well, so these distances are the same. Now, what we could do is take moments about any point here, and let's take moments about P. You could take moments from anywhere. So let's look here. If we took moments from here as it's hanging, there is from the point here, there is this force up where it's hanging in that direction, and that is going to be at this distance from P. Now you see, here is where we have to know our angles. If that's alpha, that is alpha here. And so we want this force times this distance. And this distance happens to be, that's the hypotenuse, PB. So we would say this force up, which is clockwise, would be m plus km. That's the total weight of the object through the center of gravity. So it would be m plus km g, because that's the gravitational force. Now this, if that's alpha, then we want that distance, let's call that C. PC as the adjacent side, the hypotenuse. So over the hypotenuse, which is PB, equals cos of alpha. Do we know cos of alpha? Let's just not worry about that for now. We could work it out, but PB we know is 2A over 3. So PC equals PB cos alpha. Adjacent over hypotenuse. Okay, so we want PB 2A over 3 cos alpha. So that's the distance, 2A over 3 cos alpha. Okay, now that's the clockwise. There is a force through here of P, but that will be 0. And then we've got this force of our lamina through this point. And so if we put, because it's parallel, the force down will be acting down. So let's get this distance. and we now have mg acting anti-clockwise around P at this distance. Call that D. So let's look at PD divided by PA, which we've already worked out. So PD is, PA is 14A over 3 cos alpha. So that's the distance that our moment of mg is away. So it will be 14A over 3 times cos alpha. All right, let's cancel these cos alphas because cos alpha is, we didn't have to find cos alpha. There's a g on both sides. And let's factorize this bracket here. 1 plus k times 2a over 3 equals m times 14a over 3. Well, we can cancel the m and we can cancel a. That's convenient. Therefore, 1 plus k equals 14 over 3 times 3 divide 2. And that will be 7. 1 plus k equals 7, therefore k equals 6. So k equals 6. All right, so we've looked at a centre of mass question where they've given us a circle with a circle missing. Let's have a look at the answers here. Okay, we showed a similar area and location. I'm not sure what the 4 and 1 is here, but the x is I'll have to look at that a little bit closer to see what the 4, 1 and 3 is. We've used 0, y, but we've shown it to be 14a over 3 from P. Then we have k equals 6, and so they've shown a formula. You can actually have taken the moments from any point. We found the moments from P, and this is the formula that we used. And so taking moments about P, k equals 6. All right, so that's a question on centre of mass. I hope that you can find other questions similar and practice it. And until I see you or talk to you next, I hope that you enjoy your practice and are fine with this on the exam. And until then, stay happy.